So the end goal of HAZOP, Hazard and Operability Analysis. The end goal of HAZOP is the same as other techniques that we have discussed. We're looking to identify hazards and mitigate risk so that the system is safer. But the way HAZOP technique gets there is a little bit different from what we're used to. HAZOP is a secondary technique that uses keywords to help identify every conceivable way that the system could deviate from intended operation. Now, deviation from intended operation is not necessarily hazardous, but deviations from intended operation can help us determine if hazards might be caused by that deviation. The HAZOP process is pretty simple and straightforward, but it must be executed rigorously and systematically for maximum benefit. The HAZOP technique can be used pretty much from concept through disposal phases of the system life cycle. While it officially falls under the preliminary and detailed design hazard analysis types, HAZOP can be executed effectively at any time in the system life cycle. It is most advantageous to conduct the HAZOP early in the system life cycle in order to discover hazards early enough in the life cycle there to implement corrections in system design before that becomes problematic. Additionally, as the system proceeds through its life cycle, if you conduct the HAZOP repetitively or at different stages, after more system and operational knowledge, say, is gained, that can help more comprehensively analyze the system as you go through the different stages in the life cycle. So as we stated before, HAZOP looks for deviations. It does this by using parameters and guide words. So parameters and guide words will yield or lead us to recognize deviations. Let's talk about that briefly. Parameters, we'll start there. Parameters are limitations on the system. Those constraints, there are those constraints under which the system is designed to operate. Hazards can be identified by analyzing what happens when a system deviates from its limitations. Here's a sample list of parameters from your Erickson text. Here are a couple practical examples. The radiator coolant in your vehicle should maintain a temperature between certain limits. Another example, the hydraulic fluid in the system, in a hydraulic system, should pressurize to a certain psi. And another example, a fuel flowing through a boost pump should maintain a certain rate or flow. So those are some examples of parameters in systems. Now on to guide words. Guide words are used to direct the process of identifying deviations. They are short words that are used to stimulate imagination of a deviation from the designed intent. And here are some example HAZOP guide words from your Erickson text. When you put the guide words and the parameters together, you identify different ways the system can deviate from the designed intent. For example, the radiator coolant that we talked about before should maintain a certain temperature, or a temperature between certain limits. Using guide words, we can see that more would be high temperature, less would be low temperature. Both high and low temperatures are deviations from the system's design. Another example that we discussed, fuel flowing through the boost pump should maintain a certain rate. That'd be flow. We might consider some of the obvious guide words. That's more, less, none. But then we also have some less obvious, and that's part of the reason for going through HAZOP in a systematic way. Say we have as well as. That's another guide word. Flow as well as could indicate something else, a deviating concentration. Say a fuel line cracked and air was introduced. It's a different concentration of fuel flowing through the system. So when you put the parameters together with the guide words, you can brainstorm comprehensive ways in which the system might deviate from its intent and intended design. With those deviations may come hazards. So we work through that process in the recommended HAZOP worksheet that looks like this. And note that we are working almost backwards to get to our hazard. Our hazard is way down here in the spreadsheet. But let's see what that looks like. An example given in your text is related to a steam generator system. There are some assumptions that are depicted in your text and in your PowerPoint. So here are some of the assumptions. Water is supplied from the tank to each of the 3 steam generators. 2 of the 3 generators must be operational in order to ensure coolant. Pumps 1 and 2 are electrically driven. Motor operated valves 1 through 4 are electrical driven. And then our last key information, or our last assumption here, pumps, motor operated valves and generators are controlled by a single computer and a common electricity source. So let's perform a HAZOP. Let's use this information to develop a HAZOP, and for time purposes we will not complete an entire HAZOP on this system, but we'll do enough to illustrate the principle for you. The items that we will analyze are pipes and electrical power. These go into the item column. Next, identify the purpose of the item under analysis. This is a description of the operational intent of the item. And that's pretty straightforward so far. Pipes are to carry the fluid, and electrical power is to provide electricity, right? To the specific things that we're providing electricity to. Now we are into the technical aspects here in the parameter column, technical aspects of the HAZOP. Identify the parameter or the limitation to be considered. If you need help remembering key terminology for parameters, you can refer back to your Erickson text, page 306, which is on table 17.3. So we list parameters here. For our 2 examples, fluid through the pipes and electricity for the electrical power. Now, continuing, we consider guide words. Guide words in relation to the parameter. Put all guide words in this column that are selected for analysis, even if they don't have any impact as far as deviation. In our example, to keep it under control, we're not going to use all conceivable guide words. We're going to give you some so that you can understand the concept. For a more comprehensive but not all-inclusive list of guide words, but to get kind of your memory jogging in that area, you can refer back to the Erickson text again, page 307, table 17.4. Consequence identifies, the column consequence identifies the most immediate and direct effect of the guide word if it occurs. So what happens if the parameter deviates as per the guide word? What is the deviation? That's what goes here. Causal factors, by contrast, are those things that could cause the consequence. In other words, take the deviation that you listed in the previous column and identify in this column all the ways that that deviation could occur. Note as well, please, though, that deviations or consequences are not causes. They are different. If a fluid pump fails, flow stops. This is the deviation of the consequence. Flow will stop. Pump failure is one way that could happen. It's a possible cause. Pipe leak or rupture. The pipe's leaking or the pipe's rupturing. That's another cause. List all the causes in this column. But remember the difference between cause and consequence. Then, given the deviation noted, what hazard might result? The answer goes here. And then we identify the risk as per standard definitions and classifications, and then we provide recommendations for system safety requirements, design requirements, and hazard mitigation strategies to reduce the risk and enhance the safety of the system. So that's, in a nutshell, the HAZOP technique. It's pretty straightforward, it's pretty simple, but it must be done systematically and rigorously in order to provide maximum effect.